And I welcome you to the week, what is it, week 7? Yeah?
6.
Week 6. Ah, Vasco is there.
Hi,
Bom dia.
bom dia, bom
Okay.
dia.
So, so we're going to talk about the Make Something Big today, which is kind of the coolest class. I will share my screen and stuff. Let's see where my wiki is. So probably you realized that I'm extensively documenting the classes from Neil. So from yesterday, starting with the regional meeting, I don't know if this is a time that fits for you. It's always at 1 o'clock on Wednesdays. And I think it's super inspiring to see what other people are doing. I don't know what Hank is doing to his students, but they are all documenting like crazy. Like I think it's, for example, Paula. Like I quickly went on her page for seeing for taking the photo, and I started scrolling, and then I realized no, I won't get far with scrolling. It probably takes you 5 minutes to just scroll through the page. Like you need a motor on your scroll wheel. If not, you won't you won't get anywhere. Like that's like, yeah, if you have a look, it's like really well documented. Actually, yeah, mostly everybody in Amsterdam is documenting like every little step. Super nice. We're looking forward to seeing Nicole for her next assignments. She found a school that has a UV printer. So in parallel to milling the boards, she's also doing etched boards. And this UV printer is able to not just print the etch resist and the oh, this is the wrong page. It can also print in color. So her next oh yeah, she presented in class as well. I don't know if you saw it. So she made the board with her own little milling machine. She has the same machine that Vasco has, and she even made like a video of how to assemble it. The video is not online yet because she's still compressing it. So she has a step-by-step how to assemble her milling machine, and at some point a little bit later, she shows off this UV printer, and oh yeah, this is Ostfriesland, which is a region of Germany in the very north, and so soon she's gonna make a board including the color of the Ostfriesian flag. For the moment, she's just etching it, but etching is not considered okay for FabAcademy. For FabAcademy, you have to mill your board, and yeah, really looking forward to what's gonna happen there. Nadi, as always, she's amazing. Like each class, she does something beautiful. Very extensive documentation. I found a few nice links. Like she's for connecting the ground. She makes a keep out area. So first, like you see that this little piece is left out. So you can define a keep out area in KiCad. She also links to the Aalto KiCad tutorial from Christianis, which is probably worth having a look. And
Just
there's
for that
also
one is in Eagle. That keep out is in Eagle. The one on that you showed, it's in Eagle. This one, yeah. No, not this one. This one. The image is in Eagle, but there is a similar option in KiCad.
oh, this image is
It's from Eagle as far as I know. Yeah. Or
oh, I thought she designed in KiCad, but I'm not sure.
I will check it out.
Yeah, and there's also like extensive KiCad documentation from DigiKey. So this is like a lengthy video series on KiCad by DigiKey. I'll definitely have a look at this one as well. yeah, Urban, he's measuring his internal resistance and 21 mega ohms. This is quite interesting that this multimeter actually measures mega ohms. 20 mega ohms is about the same resistance you get when you put your probes into a glass of water, depending on the temperature and the amount of salt you put in the water. Yeah, just an interesting thing. Yeah, lots of boards. Then the prep meeting. So new eval is ready, and the first labs are already using it. Right now, I'm only my only lab right now is the one in Portugal. So I still have to get my students from Camp Lindford, so I can help Daniele evaluating you. But I don't know if you've seen this. You should be able to log in with your FabLabs IO account. So right now I only get now I have info. Nice. So so this is the evaluation from our side. So for each week we can check all the points. Once you're finished, you get like a green check mark at 100%. And we can also communicate to you that you're not completely finished on some parts yet. You can also see this page, so you can like communicate with us through this chat function. So when you send a message through this form, we will receive an email, and when we answer, it will appear on the same page. And that's a really nice tool for giving you some feedback. And we should start using it as soon as possible. Yeah, so now that I can reach everybody, I will start evaluating you. In the very end, once this local evaluation is finished, there's going to be a global evaluator that has the same form, and he's going to decide if the local evaluator evaluated right. So this is not our thing, but some random evaluator from the international FabLab community is going to evaluate you. And once this one is on 100%, you graduated. So there's like a little I don't have this is not defined yet, but once you're on 100%, the evaluator can click on. There's the dropped out next cycle. There's gonna be like a button here where you graduate, and it's gonna greet you with welcome, new Fab Guru. But first, it's gonna ask if you ever used glue for sticking together your Make Something Big. This is like an insider joke, because in one of the former classes, Neil commented that glue is a sign of failure for the press fit assignment. So yeah, and then people, I think the guys from the Netherlands, they made T-shirts with quotes from Neil, and one of them was glue is a sign of failure. Yeah, so we should collect quotes from Neil and make some T-shirts when we go to Canada. Okay, so much on that. Then I linked to the list of shame. So this is if your website is too big, you're gonna appear on this list. So this is really where you don't want to appear. Luckily, nobody of us is in here. For some reason, Lucio is still in here. He's from last year. He managed to upload 400 megabytes to his repository. So you should really try to stay under 100 megabytes. And you can check your sizes in your repo. It will say on top, it will tell you the size. And yeah, so I hope none of you appear on this list. And yeah, and then this was the class where I linked to all the people that were interviewed. And this was a girl from Amsterdam last year. She did a really nice little fully automated dollhouse. This guy, I think it's him. You can see that the image link goes to Imgur. Like he posted all his images on a different website, which is not okay. Like all your images have to be on your FabAcademy repo. If you have really big images or really big videos, you can put them somewhere else, but not on Imgur. Like you can put them on maybe on GitLab. Just make a second GitLab account, like with your, like you have, I think 1 GB free for storage, but everything that is essential for your assignment that anybody would need to reproduce your assignments has to be in your repo. Like the videos are optional, so you can skip them, but then also your hero shot has to be an image that is on your website. And I thought it's really funny the way Christianes was attending class with his. You can tell that they're prepared for bad weather or for excessive sunlight. Yeah, I like the "Never Trust the Autorouter" T-shirt and the 3D printed circuit. Here I posted a lot of links to fabbable furniture. I think the most known one is OpenDesk CC. It's a website where you can download designs for furniture. Actually, they're quite nice. Like I know many Fab Labs, like the Lean Desk. I already fabricated 5 of them, maybe even more. And if you click on one, you get a price. So you can buy it ready-made from OpenDesk. It's like 1,000 euros, a bit more. But the good part is that if you scroll down a little bit, there's a place where you can click on, where is it? Change request quote. Download. So if you continue, you can download all the source files for making it. You get some DXFs that look like this. And then you can send them to your big milling machine and yeah, assemble the parts, and you save, like, I think this one is like 2 sheets, which should be something like 160 euros. So you get like a 1,000 euro desk or table for like 160 euros, which is nice. Of course, you're going to spend a day building it, but I would definitely prefer building it myself to buying it. And then I put a lot of other links that have similar projects. I took this, like somebody from, where was it, where the a storage of explosives went off and destroyed half of the city. Was it in Lebanon?
Beirut.
In Beirut, yeah.
Yeah.
So somebody from Beirut was writing in the FabAcademy instructor channel, like, guys, please, like, we need furniture. Where can we get furniture? So I sent them this whole list. Yeah. There's some, like, Sketch Chair is a really nice one that is a friend of mine that made an open source program for designing chairs. Tiago Rorque, that lives in Lisbon. Vasco, you should really meet him. He's one of the most amazing makers I know. And yeah, so there's plenty. And
What's his name?
Tiago Rorque.
Okay, okay.
Yeah. And yeah, you should download some of those files, have a look at them, just for getting a feeling. You could also, as a practice, make the G-code for one of them in Fusion. Yeah, there's some really nice stuff there. Then I put some links. Somebody was talking about milling glass. So there's a video from open source, from Applied Science. He cuts glass on the big milling machine, which is quite amazing. I put the link for the reciprocal frame structures. Did somebody catch what Neil exactly meant with Maxwell? like I have to watch the video again and update this. There was something about Maxwell, but I didn't catch it.
Yes, it was about degrees of freedom and optimization of degrees of freedom regarding the dimensions.
Okay, yeah.
Okay. So you have to you could constrain the whatever you are doing with the right constraints. Number
Yeah,
of
I think it was related to the tensegrity structures, and yeah. And this link is also quite interesting. It's quite old already, but it's still awesome. So it links to the 50 digital wood joints. So it's a collection of different wood joints inspired by Japanese carpentry, and it's a heavy download. It's like 49 megabytes, and it comes with all kinds of cut files, which are not directly usable, but they're definitely inspiring. If you look at the PDF, there's some example structures. One of them, they call it the meander shelf. It's a complete shelf out of one piece of plywood without any leftovers. So it's just the cuts, and it creates tags and the shelves in one go, and there's nothing left over. So this might be another challenge for this week. I'm trying to make something without wasting any wood, which I think is really cool. But yeah, of course, optional. And then this one, I think, is a paper from a Japanese interactive design and fabrication of wood joints. So they do these types of structures where, you know, these how do you say, Knobel games? Like it's like a brain twister where you have a cube, and once you push one piece, you can disassemble the whole thing. But it's like one key piece that keeps it all together. And I think this is kind of going in this direction where you build a structure that is only held together by one piece. So if you take this piece out, you can disassemble the whole thing, no screws, no glue. And if you put it together, once you put the last piece, it's all rigid again, and you don't have to, yeah, you only have to follow the instructions very carefully. And here's another PDF for Japanese wood joints. And yeah, so the Japanese going crazy with their wood joints, and it's definitely a good inspiration to have a little look at it. Yeah, I think I found this PDF somewhere. Not sure if it's like completely legal to post it here, but yeah, just don't tell anybody. Yeah. Okay, and then yeah, actually today my class is going to start by showing you how I use Fusion. I think I use it a bit different than most people, and I'll also explain you the reasons. But after watching this video yesterday, most of my reasons just disappeared. But I will tell you anyway. Oh yeah, Vasco, thank you. I will copy the link in the wiki as well. Yeah, and then here's some stuff that I just picked up in the chat. I haven't looked at it yet. I don't know if it's good or not. But here you can see that they're just doing some test fits. And this is something we should definitely do as well. So before you design your piece of furniture, you should make a single joint. It's similar to what we're doing for the laser cutter, where we check what fits together well. And it's the same thing for the big milling machine. So if you don't do this, you might have to sand a lot. I can quickly show you my make something big, which I did in the Fab Lab in Lisbon, and I didn't have much money, so I tried to keep it as cheap as possible, and I found some material that is like half MDF, half cement. It's a very weird material, but we had a lot of it left over, and so I milled, and I needed since I arrived in Lisbon by bike, I didn't have any furniture, and what I urgently needed was something to put my clothes, and so I made myself a wardrobe. But it did look a bit boring, so I decided to make a little pattern on the front door, which was actually quite funny. It's using a program called Alchemy, which kind of helps you to be creative. It doesn't draw straight lines, but it draws wiggly lines, and you can affect them by, for example, by the speed you're drawing with. Like the faster you go, the wigglier the line goes. But you can also affect it by sound. So if you draw in silence, you draw a straight line, but if you scream, it makes a wiggly line. And so this took place like somewhere, like I missed the last bus for going home from the Fab Lab. So I stayed overnight in the Fab Lab. I slept on the milling machine. And somewhere in the middle of the night, I was trying to make a nice pattern, and it just didn't work out until at some point I was just going like, ah! And this was the pattern that came out. And I spent the next few years looking at this pattern, because it was right in front of my bed. And I really like it because you can see all kinds of different patterns in there. Like I can see a bee in here, and then there's like a big face also. And yeah. So this was my Make Something Big. I used the wasteboard from the CNC machine as the back cover, as you can see. And you can tell that we milled a lot. The only thing that I didn't do properly is I didn't make the test fit. And so, of course, 0 on 0 doesn't fit. So I had to sand all those single pins. I spent a day sanding. So please don't make any constructions where the interior is the same dimension than the exterior. It definitely
the important thing is you didn't glue.
Yeah. And so I took those joints from this book that I showed you. So this one, and you fit it together, and then you insert this long stick, and this keeps it all together.
Ferdi, what's the advantage of this cement mix with MDF material?
It's horrible. Don't use it for anything. It's supposed to be like a facade material, and actually they built a schoolyard in Portugal from this material. But after a while, the pupils realized that if you kick it with your foot, it breaks. So they broke the wall and they redo everything. So yeah, it's heavy and water resistant, but it's absolutely not usable for making furniture. Like this box here,
right, yeah.
It weighs probably 20 kilos. It turned out really nice, and so I made these hidden wood joints. The Japanese call it Gomai Hosogata, like doing this by hand is really challenging. And so you can read this quote where it says, "Out of awe for his material, the cabinet maker humbly conceals his own efforts in making a piece of furniture." With the CNC machine, this works super nice. And actually, I could assemble this box like on this one. It was to my advantage that I didn't leave any gap, so I could just hammer it together, and then the whole box would keep together without any glue. But yeah, but this didn't work for those. So if you're not planning on making press fits, give it some clearance. And so one of the things I learned is never trust the thickness of your wood. So before you start milling, you should measure your source material in all corners, because especially MDF, like depending on the quality you buy, they put the nice layers on the outside and they put lots of crap inside. So it might happen that your plywood is thicker in the middle than on the sides, which shouldn't be a big problem, but this also leads to your wood not lying completely flat. So if you have little tabs that are supposed to keep your piece attached while you're milling it, if your board stands up a little bit in the middle, you will mill away those tabs because they're not measured from the ground but from higher up. So measure your wood just for knowing what you're at. Yeah, 1-to-1 fits too well. Consider the weight of the pieces. Yeah, so this was my mistake, that I didn't take into account that this wardrobe is going to be super heavy. Fusion allows you to, if you give it the density of your material, you can pre-calculate the weight, and that's just a good recommendation. Before you start milling, and double check if what you're building doesn't weigh a ton. And don't ever assume that your wood is flat, because it never is. So, and if it isn't flat, you can accommodate for this, but it's good to know if it's flat or not. And if you go to buy plywood, take a long ruler or pick something flat and hold it against the wood, or put two boards next to each other, so you kind of have an idea if your plywood is warped or bulged or something. Okay, and yeah, and I guess we can jump into Fusion now. So if you want, you can open Fusion as well. And I first have some general advice for working in Fusion. For some reason, my Fusion is not happy. Actually, it never is. Fusion is giving me lots of trouble. Each time I start Fusion, it crashes. And that's what it is doing right now. So I might just as well close it. But sometimes I even have to restart my computer for Fusion to start again. It doesn't get along with Blender very well, so definitely close any other 3D software before you open Fusion. If not, you get a screen like me. It might be that it's unhappy with my camera right now. I have no idea. Yeah, so normally I would wait a few minutes, but I know Fusion, it's not going to recover. And I'm almost sure that if I start it again now, that it won't start. Yeah, please pray for me. But yeah, for the first part, I can just start telling you my story of Fusion. So you know that Fusion has this way of having, it doesn't distinguish between assembly files and part files. It's all the same Fusion file, and which is unusual. Like most other CAD programs have part files and assembly files that are different, obviously. And Fusion mixes it all together. So you can yeah, have assemblies made out of assemblies or out of part files. It doesn't really care. And most of the Fusion tutorials you watch, they recommend you to do your whole assembly in one file, and that's actually okay. Like, but once you get to parts like, let's say you want a bearing or a NEMA 17 motor, or something that you get from like a CAD library where you can download like standard parts, then you can only insert them into Fusion as an external part, which is shown by like a little chain symbol, which means that it's an external part. And the only stupid thing about this is that from those external parts, you normally can't access the parameters from your assembly file. Okay, so I started Fusion, but it doesn't open. Not sure what to do. I think I might have to restart my computer, which is a bummer, because then I have to restart the recording and everything. So I already clicked Fusion twice and it's not doing anything. Let's see if something's appearing over here. It's not appearing. Okay, one last try. If not, we have to pause for a second and I'll restart my computer. Yeah, stupid Fusion. Okay, yeah, I'm sorry. I will restart and be back in the meeting in a second. I just have to stop sharing. I don't know if I can come back after. Yeah, let's try. I will pause the recording and be back in a minute. Okay, I'm back. Fusion is happy now. I guess I have to. Whoops! I have to share my screen. Can you see and hear me?
Yes, we can, Freddy. Also, your screen is fine.
Yeah. Okay. So this is a little construction I made recently for one of the students from the IP project. It's like a little Delta robot, and you can see that it moves like this. I didn't use the there's like spherical joints, but for the spherical joints you have to define the degrees of freedom. If not, it will just like go crazy all over the place. And I was just too lazy to define the limits for each of the joints. So here I just made like a cylindrical joint. Actually, it can move in all directions, and you can see that all my components are external components. I did not use the regular Fusion way of doing this because I like having my files separate, so I can also open them in a new window. And it's maybe part of it is habit from like SolidWorks and Creo and ProEngineer, but the other part is that I couldn't find a good way of how to arrange my pieces on for fabrication. And I'm very sorry, I had all my files open on the last session. Now I have to find my example file for this week, which unfortunately I think is in another project. So you also can't share files between projects. So once I have several users. Right now I'm in FabLab Kali. And once I switch over to my personal account, this is gonna close and it's gonna disappear. The only way I found so far is you could export this as a, I think it's called X3D, or I forgot what the Fusion format is, but you can export your projects to disk, and then you could import them in the other workspace. But yeah, since I can't have both of them open at the same time, I will just show you some little things on this one. And if you look in, and you can also see that I have all my files here on the left side, and I can assemble them just by dragging them into here, and then make my constraints. You can also see that I kind of strictly follow this of I place my part and I make a constraint. So the very first part you put has to be rigidly connected to your assembly, and I do this by using the it's called the as-built joint. So usually I use the as-built joint for my very first piece, and you have to select your piece and your main assembly, and then it's going to be yeah. So it doesn't say as-built joint, but if you go to edit joint, it tells you that there's two components. One is this one, the base, and one is this upper one. An easy test to see if everything's all right is if you turn on the origin and you click and drag on one of your pieces, it's not supposed to move. If you can move it around relative to the origin, then this is not a good assembly file. The pieces shouldn't move. And this is not tragic if you're just like making a wardrobe, but once you want to have it move kinematically, let's say you want to open and close the doors, if your first part isn't rigidly connected to the origin, then your whole wardrobe will move. And if you want to do something like the delta kinematics, where you can move the whole mechanism, this only works if all your assemblies and sub-assemblies have a fixed part. And there's also this, let me close this one. And there's also, there's one joint that is, I know, you can also right click on a component and say, there should be one option that is ground. And ground, you shouldn't use it for attaching your first piece. Ground is more for, like, let's say you're assembling the stud robot, and at some point in time, all you're in random directions, and you want to make your next joint. Oh yeah, is it called joint? Yeah. And it might sometimes be useful to just freeze everything for a moment, temporarily. And this is where you can use the ground. And this ground appears as a feature. So you can skip it or suppress it, then everything is movable again. And once you ground it, it will be phased. But this is just a temporary thing. It's not part of your assembly. And so you can see that my whole assembly starts by inserting a reference. It's called a derivative. And a derivative is my solution for passing on all my parameters into my separate files. So I start by building something that I call a skeleton model. So in other CAD programs, you actually have a part type that is called skeleton. In Creo, there's assembly files, part files, and skeleton files. And skeleton files have the property of they can't contain geometry or 3D geometry. It can only contain planes and axes and points, but there can't be any geometry in here. And so I start by making a skeleton file, which is just roughly representing the main structure of my file. All the important dimensions are in there. All the parameters are in here. I'm not sure. Yeah, so here you can see all the parameters I used. And if you select a sketch from this skeleton model, and you click on derive, I have to save, okay. Then you can choose geometry. In this case, I would choose the sketch. And so this sketch is kind of exported to somewhere else. And once you click OK, it will ask you if it wants to create a new file or if you want to incorporate it into another file. And so usually I incorporate it into, in this case, my main assembly file. And then, so my assembly starts by this derivative coming in, which is just the very first sketch that I pulled from the skeleton model. And so now if I change my skeleton model, all the part connected to it by this derivative. So let's say this is the base, and since it's a separate file, I can open it in a new window. And you see that in the base, first thing I do is I get the derivative from my skeleton model. So all this geometry is based on the skeleton. And if I change my skeleton, this file and all the others will update accordingly, which is super helpful because for example, in this case, I had to move the motors a little in the very instead of like going through all the parts and updating the dimensions. It's just a one-click action and everything's up to date again. Of course, you get this update button. So since I changed and saved the skeleton model, now I have to reload everything. For some reason, it takes a while. But yeah, this should just disappear. I don't know why it's not right now, but you get the idea. And most other CAD programs do this automatically. So this stupid, I don't know what it's called, but yeah, this is. I'm sure there's a way where you can do this, where you can auto recompute. Okay, now now it did it. Okay. Yeah, so all of my files they accept like derivatives from the skeleton model, and then I can control my whole model, including all the parameters from one file. So let's say you have you're building your wardrobe, and you want to control. Let's say your hinges are something that you imported from some of the partserver.com, or there's like, but I think we talked about this before in computer-aided design. There's lots of pages where you can download a lot of parts. This one from McMaster Car is also very useful because they have a lot of good 3D models for Fusion. But let's say you want to change the position of your hinges in a skeleton model so that all your, let's say your doors update so they have the cutouts at the right place. I wouldn't know how to do this in a Fusion file where everything is integrated into one file. I would do it like this and use the skeleton model with the derivatives. If you import parts, like for example the NEMA 17 here, which kind of has to be an external file, because yeah, if you don't redesign it in Fusion, it's going to be external. And so this one I imported as a step file. And if I do my little test and I just click on a part and drag it, we can see that all the parts are loose. And this shouldn't be happening. And this is why I constrain all my parts. So I make all my joints. And now the very first one is the one where I tie one piece to the coordinate system of my file. And then all the others are attaching to this very first file that is rigid. And now I have a file that I can actually work with. If not, whenever I move the Delta robot, my motor would like fall apart in all its pieces. So make sure that your very first part has an as-built joint and all the other parts are connected to it. Any questions? No? Then I will just continue by going to my personal account, which is this one. And there's the amplitude. So this is a model that I created in Sketchchair, like the one that Thiago Rorke made. And there's a few files that are already generated that you can just download. And this one is kind of famous. First time I went to the makerspace in Beijing, I was shocked to see that they had like 20 Ampler chairs standing in their makerspace. And I was very surprised, and turns out that Thiago was there for a visit and he showed them how to fabricate one of them. And so they made another 20. So all the chairs in makerspace Beijing are Ampler chairs made by Thiago. And in this case, I imported the DXF. Well, actually, I think it was a PDF that I converted with Inkscape to a DXF that I could then import into Fusion. And then in Fusion, there's a way where you can separate all your bodies into components. Oh yeah, this is also an important thing to note. like if you start working the fusion way, all your parts are gonna be bodies. And if you wanna use the assembly constraints, they have to be components. And but you can just right click. Like let's say I had a body in here, which I don't. You can right click on a body and convert it to a component. So in the end, all your pieces should be components, not bodies. And yeah, through this workaround, I created all those pieces and I assembled them together. And yeah, so in my case, they are external components, but internal components would also be okay. And so yesterday I discovered this new plugin for Fusion. Well, actually, it's not a real plugin. I don't know how they call it. But after watching this video, and I think this is already linked in the wiki, it's still quite new. So it's like from 2nd of March, and it shows you how to do advanced nesting in Fusion. And actually, you have to make some adjustments in Fusion for this to appear. I think first of all, you have to click on your profile, go to Preferences. And this should open a window where you can go to Preview Features. And scrolling down, like actually there's lots of interesting stuff hidden in here. Oh wait, am I recording? Just a second, double check. Yes. Actually, the generative design is really interesting. I didn't know about this, but here you have to, I think you have to enable it for it to appear. And in manufacture, there's this checkmark for advanced arrange that is not on by default. So you have to check this one. And also in, I think it's in general. Well, this is all in the video as well, but it's in general design, and you have to enable arrange in simplified tools, which is the lowest one on this one. And once you do this, a new feature will appear under modify, which is called arrange. Okay. So my main reason for not for working with the external components is that I could make two assemblies, one which is just the assembled chair, and I could make another assembly which is all the pieces lying flat on my original piece. Here I just put two of them because I was too lazy to arrange all of them. But this would be the file where I would switch to manufacture and do all my CAM stuff in here. So I usually design my stock material. Then I place all my components in the same assembly. And then I do my CAM operation. And if you don't do this with the external parts, I wouldn't know how to reassemble my piece in the same file. Of course, you could use the align feature, but then you would have to realign each piece, which is like a lot of work. And it's much easier to just have a second file, so one for the chair and one for the manufacturing. But yeah, but now I'm using this arrange tool. Fusion does it for you, and not only does it put everything flat automatically, it also nests it in a nice way. So you can just select all your objects. Then you go to Sheets, and you select a plane. And you give it the size of your stock material. And the usual size here is 255 by 125. And once I click somewhere else, Fusion starts thinking. and it will lay all those pieces. It will, yeah, try to fit all those pieces flat onto this plane. Takes a second.
The sheet margin and border spacings are relative to the spacing between the different parts.
Yeah, so sheet margin is the distance from one piece to the next. I would increase this a little bit. So you want your 6mm mill to pass through. So 6.3 would actually be enough, but yeah, I would make it 10 millimeters just for good measure. Because in places like this one, once you cut through here, this piece would basically be loose. If you very carefully arrange your tabs, which are the little pieces that keep your workpiece connected to the stock material, then you can actually live with 6 millimeters in between. But if you like, you also have to think, like, once you cut out all the pieces, your single pieces are they are secured by the screws that you put in. But if the flux of forces goes through like a very thin wall over here, and you push on this piece, and this thin little wall is the only thing that connects your piece to the closest screw, then this might break during machining. So you either have to put lots of screws or leave tabs that are big enough for taking your forces from the mill. Actually, I could show you a design that was made by one of my students in Lisbon. His name is Delio, which was kind of fun. Like he became a father in the last weeks of FabAcademy, and so his oh wait, I have to go to program. So his make something big was a crib for his little boy, and computer controlled machining. So he made a really nice design in SolidWorks. And you can see this is the nesting of his design. And you can tell that there's hardly any space in between the pieces. So if you were to cut this out, you would see that this middle piece is only connected by some very weak bridges in between. So if you just secured this with like 4 screws on the corners, this would definitely break loose. But we found an interesting solution, which is by putting the tabs in the right places. So this is the simulation in Aspire. Okay, and you can see that the tabs are arranged in like straight lines. And if they were just like randomly placed, your pieces would bend and break when you cut them. But by arranging them neatly, it was rigid enough for milling the whole piece without breaking. Of course, we did the first test fit, unfortunately with an upcut that left like a horrible finish. But this was good enough for testing it. And here you can see the process. And here you can see the finished piece. You can see the finished piece with all the tabs and connecting the pieces together. And yeah, so this wouldn't be possible without the tabs. Those pieces would just go loose and start going crazy on you. And here's the finished verso. Yeah, it was a really nice project. Okay, so back to here. So yeah, remember that your sheet margin is might be the only thing keeping your pieces connected. And if you don't use plane, you can also use sketch face. So I made a sketch which is roughly the size of my wood, And if I go to arrange now, and I select all my pieces, I can also select a sketch, which would be this one. And you see that I drew a circle. So imagine you have a piece of stock material that already has like a corner missing, or somebody like cut a stupid circle out of the middle, which you shouldn't do. Like you should really put your pieces neatly in one corner so you don't waste material. I left the sketch completely unconstrained, which is also something you shouldn't do. But in this case, it was just for the sake of demonstration, because since there's no dimensions, now I can just go and drag. I think I can even say OK here. And now if I change the size of my plywood, Fusion will automatically recalculate and arrange the pieces in a new way so that they fit on the board. Go Fusion. Yeah, you see, so it avoids the circle. If I take the circle and put it here somewhere in the middle, it will rearrange the pieces so that in order to avoid the circle, which is super handy. Unfortunately, I only learned about this yesterday. So it might make my whole construction technique with external components obsolete. But I think it's still useful for being able to use external components, including the parameters. Okay, I will switch back to my, how do you say, old school way of doing this, where I design my stock material first. Then I place my components just by dragging them in and moving them around so that until I'm happy with them. And I usually like my favorite technique, and also Neil's favorite technique for securing your work pieces, is by using wood screws. So you just screw through your stock material into the waste board. You can see that in Delius' case, we did not have a waste board on the machine. So you can see those clamps on the side. They're just like little brackets that hold it down. But it's very likely that sooner or later you're going to mill into those clamps. Fusion offers the possibility to include those clamps in your design. So the G-code will avoid those clamps. Aspire didn't do this. So yeah, we broke a lot of mills by hitting those clamps. Actually, sometimes it's almost funny because you watch the whole thing being milled and you're like, oh, it's almost finished. Everything good. We didn't break any mills. And then it drives, at the end of the program, it drives back to the home position, and on the way, it breaks the mill on one of those clamps. Yeah, so this is also an alert on, when the machine is running, you can only, how do you say, it's only finished when it's finished. Like, don't lose concentration. Just because you milled like 99% of the board well, it still doesn't mean that you're not going to break a mill with something stupid. Another usual mistake is that if you don't use the tabs to hold down your pieces, the pieces might jump out. And so they're a little bit higher than the rest of your board. And this is also something you can break a mill on. Like if they lie in like one side up and you drive over in a fast move, tack, you lost a mill. So my favorite method is using screws. But if you're not careful, you might accidentally mill into one of those screws. And this is why I place those screws already in Fusion. So I don't place them manually on the machine, but I make a sketch where I design all my points. So this is just I guess it's this one. So this is just a sketch using points. And I just click them in there. I don't dimension them. You could make sure that you have the proper distance from the border. But yeah, I just click in for this is completely random. But once you have all your pieces, you can kind of tell where the good places are for securing your workpiece. And you don't have to be stingy with them. Just like put a lot of screws. It's the loss is much bigger if one of your pieces moves than the 5 minutes of screwing them in. And so once I'm in the manufacturing mode, my very first operation is a drill cycle. So of course you have to make a setup, and this is again one of those things where my philosophy comes through. I put the 0 at the bottom of the board. Many people put the 0 on top, but then if your wood thickness is not exact, then you will mill into the wasteboard, which is not a big deal, but over time your wasteboard will get messy and you have to skim it again if you want to like all your dimensions in Z direction. So let's say you have like a joint that where it matters how deep the pocket is. If you don't have a proper flat wasteboard, then you won't be able to have dimensions that are correct in the Z direction. So your wasteboard should be clean, and you should put your 0 at the bottom. Like if your wood is a bit higher, then that's not a big deal. Like if your first pass is milling a millimeter deeper than what you expected, not a big deal. But if you set the 0 on top, then you will mill into your wasteboard, which is going to cause you trouble later in the game. And I had long fights with people telling me, no, but I need to mill into the wasteboard in order for the pieces to become loose, which is not true. Like if you have a properly milled wasteboard, then if you cut down to 0, it will completely mill away all the wood. Like there's in the worst case, there's like a paper thin something that keeps your pieces attached to each other. But this you can just break it with your finger. So yeah. And then there's the people saying like, oh yeah, but I use a round end mill. Actually, there's very few reasons why to use a round end mill. Like what Neil explained yesterday. It mostly makes sense if you have like 3D shapes where you want to have a coarse roughing and still get like an acceptable surface finish. But if you do 3D toolpaths with a square end mill, your surface is going to be just as good as with a round end mill. But then there's people arguing that if you use a round end mill, you have to like cut into your wasteboard by at least the radius of your round end mill, so that that your corners are nice. But that's stupid. Like don't use a round end mill for cutting out your pieces. Use a square end mill and you don't have any problems. But I spent like 3 years arguing over not milling into the wasteboard in Barcelona. Not sure if they finally got it, but for example, a friend of mine who works at IED, it's a very big school in Madrid, which fabricates a lot of stuff on the big milling machine. And he's the local instructor. And he was the one that I built my milling machine with. And I introduced him to this skimming the wasteboard and putting the 0 on the bottom. And now he's completely religious about it. Like he's like, I will make myself a t-shirt which says like put the 0 on the bottom, because this makes his life a lot easier, and yeah, and it makes all the sense. Yeah, so in FabLab Camp Lindford, we still haven't skimmed our wasteboard, which is probably going to be the first thing I'll do once we fabricate something big. And yeah, so I would please ask you to put your origin on the bottom, not on the top. But yeah, if you give me a good explanation why you would put it on top, then I will argue with you. But yeah, I don't see any reason for putting it on top.
Ferdi,
Yeah.
is there any strategy for putting the screws? You just put around the pieces to. What should be the strategy?
For where to put the drill holes?
Yeah.
It's just by like I usually imagine my mill going round,
Mm-hmm.
and the way it's pushing the material. So I want my piece to stay connected to the screws. So even if there's like, of course you have the tabs, and if you kind of have to think about how if I push on this corner, yeah,
Mm-hmm.
then the force is going to go to the next tab. Let's say actually I can preview this so you can see my tabs. Where is it? Oh yeah, here's my drill pass. It's my milling pass, my contour pass. So here you should be able to see the tabs.
Okay.
So if I push here, which your mill is going to do, the force is going through this tab to the next screw, and the next screw is, where is it? Yeah, my next screw would be either here or there. So you just have to like play it through in your head. You don't want anything to move when you push on this corner. So you have to see the flow of forces and how your piece stays attached. And yeah, the more screws you put, the better it's gonna sit in there. If you're too lazy to like, usually I take a chisel, and with the board still lying on the machine, I take the flat side of the chisel and align it to my part, and then I just go pack with a hammer, and it breaks all my tabs, and I can take the piece out. In some cases, it makes sense to screw on your part. Let's say you want to make a flywheel that is going to be like a pulley for your self-built lathe. Then you want the outside perimeter to be nice and clean. And but you're going to have a hole in the middle. So there's nothing speaking against putting a screw in this hole, since you're going to cut it out anyway. So you can cut the perimeter without tabs, and it's the screw hole in the middle that keeps your piece attached. And in the worst case, you have to like remove the screw before you drill the hole. But yeah, like from experience, round parts, they don't pop out, whereas like irregular shaped pieces have the tendency to lift up in the last pass. But yeah, I would never rely on the geometry for keeping your parts down. Like, put the tabs. It makes your life a lot easier, and it keeps your adrenaline level down while you're milling. Like, you don't want to stand there being like, oh, is it gonna pop? Is it gonna pop? So yeah, just put tabs, and your life is gonna be a lot more relaxed. So I'm just trying to recalculate the 2D contour. So I have to double click it, hit OK.
Okay,
So
and tabs are placed placed how it is the manufacturing process that puts it. You have to insert some rules, something like that.
You mean for the holes?
For the tabs.
I will show you in a second.
Okay.
This is part of the 2D contour.
Right.
Okay, so I am my very first cycle is I go to drilling. Like, this is just the drill cycle. There's you have different choices for the drilling. Like this is all of those. I'm very, like, most of the time you want the deep drilling where it completely retracts. So especially for drilling deep holes, you want the full retract. You could just drill like in one go, but this might give you trouble if you're drilling a deep hole. then if you're drilling in plastic or metal, it makes sense to do the chip breaking. So like if you're drilling, you normally want a rather slow RPM from the spindle, and there should be two spirals coming out with the chip that you're generating, and especially in plastic and aluminum, those spirals will get big and they will start to mix and make a tangle around your mill, and it's gonna swirl around, and it's first it's gonna destroy your surface because it leaves scratches from like just whirling around on top of your part. And second, it's dangerous because they might get caught, or you might be stupid enough to grab in there and try to pull them away, which is gonna cut your fingers if it's aluminum. And it might even like pull you towards the spindle and then spin your finger and the rest of your body around the spindle, which is dangerous. So you should avoid like this nest of chips. And one strategy is this chip breaking. So your mill will quickly go up and down again, and this will break the chip. So you get like shorter pieces of the chips. And just out of habit, I use the full retract. In this case, my hole only goes. Oh yeah, actually, it goes to the bottom. So when I drew the points on the bottom surface, and if you select those holes, in this case it's 7. Fusion will automatically drill all the way to the bottom, like up to where the point is. And so here I gave it an offset of 15 millimeters. So basically it's just gonna drill 1 millimeter into your plywood. So for putting the screws, you don't need to drill all the way through. You just need a little mark so that you know where you're supposed to put the screw. So the very first thing is I just put the board onto the machine, completely unsecured. It's just lying there, and its own weight is keeping the position. And then I drill all the holes, or I pre-drill all the holes. And once this is finished, I'm gonna go there with a battery driller, and I screw all the holes. Sometimes it makes sense to, like, while the machine is still running, to take a marker or a pencil and make a little circle around each hole, because if you have like 50 holes in your wasteboard or in your material, sometimes you don't find the screw holes again. So I just mark them and then I put all the screws. Then so basically for the make something big, you only need the pocket and the contour. In this case, it's just a cutout, so I wouldn't actually need any pockets, but just for the sake of demonstration, I made a little pocket here. But this is just for showing, and if you select the bottom face of your pocket, which is the case over here, Fusion will automatically mill to the right depth. And basically you can leave all of those settings on the default. So here selected contours, offset 0, this will mill to the bottom of the hole. And in passes, you have to select multiple depths. If not, it will try to make the pocket in one cut, which is probably going to be too much. And I put, in this case, I put a step down of 3 millimeters. Like the rule of thumb is that your step down should be smaller or equal to the diameter of your mill. So if you have a 6 millimeter mill, your step down could be 6 millimeters. If you want to be careful, you take a bit less. But I usually prefer to having a bigger step down and moving a bit slower, because if you only have very shallow step downs, then you will the tip of your milling bit will wear out very quickly, while the rest of your mill is brand new, because it only cuts on the first few millimeters, or depending on your step down. So yeah, I prefer having a bit more step down and reducing the feed speed a little bit. So here I have a cutting feed rate of 1,000 millimeters per minute. I'm more used to like millimeters per second, and 1,000 millimeters, like 1,000 divided by 60. Whoops, no. So that's like 16 millimeter per second, which is rather slow. Like, you know that for our PCB milling, the default in the fab modules is 5. Now I'm milling PCBs at 20 millimeters per second. 40 millimeters per second is a good value for the big milling machine. It's fast. It's not like a relaxed one, but like a regular shopbot in like step down of 6 millimeters, you can go at 40 millimeters per second without the machine sounding like it's suffering. And yeah, actually Neil's recommendation, if your machine sounds like it's suffering, go slower. That's like the perfect advice. Another good advice is to look at the size of your chips. If your chips are just powder, you're either spinning too fast or moving too slow. You're like, if you Google for chip load, and chip load is a value that defines on like, if you look at the flute of a like, if this is the size of your flute, a chip load of 100% would make chips that completely fill this space. And at lower chip loads, you get like only a part of this. And so chips should look like this. They should look like they should almost fill the whole interior of your cutting edge. There's like tables for, like, actually in Fusion, you I think you can figure all of this out automatically by defining the chip load. No, you can't, but this is defined by feet per tooth. This depends on the number of flutes. So if you have one flute spiral end mill downcut, and this is what I would recommend for milling plywood. The mills look like this. So it's basically just one cutting edge that is spiral, and it pushes the chips down, which has the big advantage that your plywood, the top layer is very sensitive to peel up, and you get this ugly edge like you saw on Delio's on Delio's test piece. Yeah, at the time I still didn't know about downcut end mills, so we used 2 flute upcut end mills. Yeah, like I recommend those a lot, and the downcut, like if you're milling like 16 millimeter plywood, the groove that you're cutting might fill up with chips, and then your mill has to do twice the work because it also has to evacuate all the chips. If you have a good extraction, the groove that you milled will be evacuated by the vacuum that is like sucking it out. So if you have a good extraction system, this shouldn't be a problem. You can use downcut spiral end mills, and this should be fine. Like how do you say, the all-purpose end mill looks like this, which is like a 2 flute spiral end mill. You could also use this for the make something big. The good thing about the one flute mills is that you can have a bigger chip load, so you can go through vast amounts of wood much faster. One flute straight end mills, like this is what carpenters use a lot. One flute straight end mill down cut. So Google is, yeah, so they look like this. Those are also really nice. They tend to chatter a bit more because the cutting edge is a line, not a spiral, so you get some tool deflection, and this will make noise, and you can hear and see this on your finished pieces. But the chip evacuation is really good, and also most carpenters they work at insane RPMs. Like if you take a regular what do you call it, for like a cabinet maker, they have the cabinet makers how's it called, damn it, we have one of those machines in the lab which is not in the wiki yet. How do you call those machines if you want to make like a rounded corner? It looks like a router, but it's stationary. You know, the machines that look like this, but the spindle is on the bottom. I think they're called cabinet makers. Router? Yeah, well, I don't remember the right word now, but they go.
The palm router, Freddie, or the table router?
Table router, yeah, that's probably the word. Yeah, exactly. Those guys, table router, cutter. So they usually have cutters that are just massive. Like one of those machines, the cutter probably weighs a kilo. It's like really big and heavy. And they turn at like 30 to 60,000 RPM. So they eat wood like nothing. And they're also like single fluted or two flutes. Yeah, I don't see the right picture right now. I bet they don't call them routers or mills. They call them table router mill. I'm sure there's a special name for it. But yeah, so carpenters usually work at very high feed rates. And yeah, with a table router like the one we just saw, you can produce like kilos and kilos of chips per minute. It's crazy. Okay. So yeah, so I guess we're gonna use the single flute spiral end mill down cut. Of course, like an upcut two fluted end mill would also be fine. I usually take a 6mm end mill for milling something like 10 to 16mm plywood. And this is what we're gonna use this week. For the OSB, this also works nicely. Yeah. Anything bigger would be a waste of material, in my opinion. You could also nicely cut this with a 4mm end mill. But of course, the 4mm end mill is a bit more prone to breaking. But actually, like from all my tests, it works beautifully. Like since you have to cut less material, this allows you to go faster again. So I think in the end, it kind of comes up to the same. So yeah, I see more experienced people using smaller end mills, because in the end you need less energy for making the cut. But yeah, 6mm end mill I think is perfectly fine for like MDF or OSB or plywood. Okay, so this was the pocket, just for showing you, and this is like the wimpy step down. You could go deeper. The radial stock, like this stock to leaf, is actually, it's kind of like a mistake. Like, I would uncheck this. Stock to leaf leaves, it will take a little distance from your line. It will leave a bit more stock. You can also use the stock to leaf, like lots of people use it for cheating a little bit. So you can also put a negative value in stock to leaf, so it will actually mill away a little bit more. And yeah, and axial stock to leaf is just like keeping, like if you made a pocket and you had this on, your pocket wouldn't be the right depth. It would be 0.5 too high. So I usually uncheck stock to leaf, and usually there's also the lead in. Is this here? Yeah. I also skip the lead in and the lead out. I just put it on plunge, which is perfectly fine if you're working with wood. Since our, like, I think Neil quickly explained this yesterday, that there's two types of milling bits. Some where if you look from top, there's material in the middle. So you can see that if you were to plunge with this tool, it would just hit this piece in the middle and probably not cut. It would suffer. Like if you're using mills like all of those, you would have to like lead in a helix to avoid like the solid center. But if you have a cutter like the one that we're using, you can just plunge into the material. I know I lost the right tab. So if you were to cut your mill in radially, and there's something left in the middle, then you shouldn't plunge. If there's a hole in the middle, then you can happily plunge into material. Yeah, back at the wood at the normal router. But yeah, I think you know what I mean, no? So yeah, there's also a strategy where you like go ramp in to your material, which in our case is rather counterproductive, because this will rip your first layer from the plywood and look. Yeah, the safe distance is like the distance you keep from your wood when you're doing fast moves. So you can see that like here, those lines are the fast moves, and in this case they would fly like 4mm over your material. Like the more shallow you make this distance, the less time you lose in moving up and down. But the higher the risk is that you that if some of your material stands up, sometimes you have wood that has very high internal tensions. So once you cut away some pieces, it will start bulging up, because you're releasing tension that was in the wood before. And if your safe distance is too low, you will hit your part and probably break a mill. Yeah, so I think this is it for the pockets. And if you look at the 2D contour, and this is the one doing the cutout, then you just select the edge going all around, and double check if those arrows go in the right direction. Like sometimes, very rarely, they flip and you mill on the outside of your line instead of on the inside, which yeah, I've had many students, like Aspire is more prone to having this type of error, and then suddenly all your pockets are far too big because it was taking the wrong outside, so to say. Yeah, but yeah, even in Fusion, you should should do the simulation and watch closely if everything looks like the way you want it to. And here I selected tabs. So these are those little bits and pieces that connect your wood to the rest of the material. You can define the tab width and the tab height. This mostly depends on how strong your material is. Like if you're cutting a surfboard and you want to keep the surfboard centered in the material, and your material is foam, then you should make big tabs. If you're using some perfectly flat Finnish Berg plywood, then you can make your tabs a lot smaller. Like here, 1.5 is rather on the small side. But bear in mind, if your wood is not flat and it stands up in the middle, then your tabs will get milled away. Also, if your wasteboard is not completely flat, then you might also mill away your tabs without wanting to. So, like I bet if you measure your tabs after milling, they're gonna be a bit smaller than 1.5. So I would rather make them a bit bigger to be on the safe side. In this case, I positioned the tabs by distance. So every 100 millimeters on the outline, it's going to place a tab. But you can also choose to draw points at the places where you want to mill the tabs. And you remember the page from Delio that I showed you, where all the tabs were like neatly arranged so that they transmit the force properly to the screws. I would actually recommend you to draw the points where your tabs are, which gives you good control. And you also don't want your tabs like in weird places, like in here, for example. And I think right now Fusion would just put them every 100 millimeters, no matter if this is a convenient location or not. Yeah, in this case, they're kind of nice. You also want to keep them on straight parts. If they are on a curve, they're more difficult to remove. If you have them on a straight part, you can just chisel them away. If they are in a round, you have to sand it a little bit afterwards. Okay, I think that's mostly it. Let's see if there's something else interesting in here. Of course, I'm also using the multiple depths. In this case, with a step down of 6 millimeters. So as I said, like roughly the diameter of your mill. If you want to be on the safer side, you would make this distance smaller. And yeah, I think that's most of what we need. Let's see. Yeah. So basically for this assignment, you're mostly going to use the 2D pocket and the 2D contour. And your first one is going to be the drill pass, where you mark the positions of your screw holes. Then, yeah, your whole thing might be just like one contour. But if you do stuff like the one that I showed you, like this one, they are pockets. Like this wouldn't work with contour, or you might even make it work with contour, but yeah, I would make a pocket for each of those places and then have a cutout in the end. Okay, did I forget anything? Of course, you can also look in our wiki where I posted the video from the class last year. So if you scroll all the way down, so this is the class from last year. Yeah, I don't think I'm telling anything that I'm not telling today. Should I make sure if you, yeah, I'm gonna post this video as well. This is the GIF showing the new nesting functions in Fusion. And Also, if you go to our milling machine, oh yeah, this is something I almost forgot. So our milling machine is the L sign. Where is it? Like something went wrong with the picture, so they're all huge, but I'm gonna fix this soon. So this is not completely updated yet. There's, I think it's the same video than the one on the other page. This year actually was my very first visit to Camp Lindfort, where we came with a FabAcademy student from Munich that by now has its own Fab Lab. He has the most Bavarian Fab Lab in Germany. And he made a video of Carsten explaining us how the big milling machine works. And here is a little zip file where I included the machine definition. So the first time you wanna you set up your like I'll go into the setup, and here you can select the machine that you're gonna use. And if you want this to appear, you have to add a new machine, which is the milling machine, and then you can load. And yeah, and you download this file. In this file are in the zip file, there's two files. One is the machine definition, and I'm not 100% sure if it already includes the post processor. If on the post processor there's already something selected, you can just keep it. If not, you might have to where was it? I think with select. How was it? Yeah, if you go to personal, local, or browse, you can just go and I think I have it somewhere in my documents. Kali, wiki, DokuWiki. No. Then maybe it's in. Yeah, well, there's those two files in there. Let me have a quick look. Oh, it should be in there.
Ferdi, it's the file .cps.
Yeah, so in there's a CPS file, and I also put in the .machine file. So if you load the .machine, it already includes the dimensions of the machine, which you can already also find on the wiki, so the working area. And I also added stuff like the weight of the machine and like all kinds of stuff that Fusion is asking you, which is not really crucial. So yeah, I try to fill out all of this to my best knowledge. Wonder why it's not. Oh yeah, this one is still on generic. Yeah, but if you take this one, actually I can edit this, then it should already have the name of the machine, the dimensions, and it has a tool changer. Actually, we should maybe disable the tool changer. So Fusion allows you to program all your passes in one go. Like let's say I do the milling with a 3mm mill, and then I do the pocket with let's say a 3mm mill, and then the cutout with a 6mm. You could select all of those and go to post process, and it would combine all of those into one file. And in between each time it uses a different tool, our machine could automatically go pick up the right tool and continue working. But something seems to be wrong with our tool changer. So I would ask you to export each path separately, and we have to kind of manually change the tool. But yeah, so I put it into the machine definition that we have a tool changer, but maybe for the moment this should be disabled just in case. If you just click on one and post process, it will only export one of those. Okay, so yeah, this is the link to the file. This is the link to the website. I still have to tidy up the wiki a little bit. I just quickly copied all the stuff from our last wiki. Soon there's going to be all the beautiful files that Daniele uploaded for documenting how he fixed the oil system. But yeah, I still have to re-upload this to the new wiki. Okay, anything I was missing? Or any other questions? Yeah, I'm sure there's going to be more questions once we're standing at the machine, but yeah, basically you export this .nc file and you open it on the milling machine. You set your 0 point on the bottom, like as I recommended, and I usually lower the feed rate. It's a very good idea to first to mill some air, how Neil calls it. So you don't put your 0 position in the right spot immediately, but you leave it like a bit higher, and you run your program just milling air. But this will already save you a lot of possible mistakes because you can kind of tell. Sometimes sometimes you don't see certain things when you're too far away. So I might make another pass where I put my z-axis so that with the deepest cut, it would almost touch the surface. And I run this one just for seeing if everything's fine. And once all of this is good, I put my Z to the proper height, and then I can do the proper milling. And usually on most machines, you can reduce the feed rate like in a percentage. So you go, let's say 10% of your normal feed rate. And so you go slowly up to the starting point, and like normally it's not a big deal if you're moving too slow. Of course, you're creating dust instead of chips, and if you went slow all the way, probably your mill would get crazily hot, and it would burn out your mill. Like you don't want to heat up your mill. Like if you're doing everything right, you should be able to touch your mill right after milling, and it shouldn't be hot. And what else? Yeah, look at the size of your chips. If your chips are too dusty, you either should rotate slower or move faster. If you're already moving super fast and your chips are still dust, reduce the spindle speed. This, like most beginners, they always put the spindle on maximum, and then yeah, but yeah, especially for drilling holes, should spin less fast. In many cases, it's okay to have a fast spindle. Also depends on how fast your spindle is. Like if your spin goes like 60,000 RPM, this doesn't make any sense for milling wood. Like don't. You're just rubbing the tool and creating unnecessary heat. If your chips look like something that you can grab and pick up, then probably it's fine. And yeah, listen to your machine. If it sounds like it's in pain, change the feed rate and go a bit slower, or increase the spindle RPM. Yeah. There's just as an example, like there's one FabAcademy final project where somebody he built like a wristband that would pick up the vibrations from the machine and transmit them wirelessly to his wristband. So he could be like away from the machine and he could feel if the machine is in pain or not. Because if it suddenly vibrates, you know something's wrong. Yeah, so if Daniele and Ahmed don't have any other comments, then I think that's mostly it for today. Vasko, you have a machine where you can mill something big?
Not yet. I'll have to postpone this part. once I'm at Lisbon, hopefully at the beginning of April. And then we can also build the fog laser and all of that.
Yeah. Andre has the how's it called? Au, the German brand, no, this little orange machine.
The Stepcraft.
The Stepcraft, yeah. Yeah.
I don't know.
And I'm quite positive that for the Stepcraft you can just use the, like if you are in Fusion and you generate the G code, you should be able to use the, can you see the Mach 3 mill? Like a Mach 3 or Mach 4 is like the most common flavor of post-processor. So this works on most machines. I think it would work on ours as well, but since we have our own post-processor, you should use this one. So ABCDE, I think ours should be called yeah, it should appear somewhere in here. You can filter this by manufacturer, and our machine is something with E, no? E. Why is it not in here? It's called L sign, easy worker. There's no L sign in here. Yeah, but if I did everything right, it should appear in here. But I don't see L sign, no easy worker.
Ferdi, just to mention that there is a Stepcraft dedicated post processor.
Ah, yeah?
It's
Then
published in this link I just sent. So the company has uploaded its own post processor from Fusion.
Nice. Yeah. Yeah. If you find one, especially for your machine, then it's fine. My default is the Mach 3. And there's also one for Marlin, which should work for most like self-built machines. But as long as you don't have like some weird commands like the shopbot is using, oh, you didn't see my screen right now, no? Sorry, I was just going through the, maybe I'll quickly show this again. So once you click on the post process, this little window will open, and here you can select your post processor, and you can see that there's tons of them. You can limit the size of this list by excluding turning lathes and water jet cutters. Like if you go on all, this list is even longer. If you go on just milling, it excludes all the other machines. And you can also filter by vendor, which just makes this list shorter and easier to choose. And you can probably, for the Stepcraft, you can download a file from Daniela's link. And once you put it in the right spot, it should appear in this list. And there might be some settings that you can adjust in this little list, but yeah, but most probably you can just leave it on default. In the case, for example, of our, if I go to Roland, then I get a few different Roland post processors. And I think for ours, the best one is the Roland RML. And then in this box, you still have to choose, like there's several flavors of RML. So for the MDX40, you have to choose this one. If you take this one, you will get like a G-code error. And like most G-codes are very similar. The thing that differs most are the so-called M codes. For example, our machine uses an M code for the tool changing, which is not standard. So you will have to use the proper post processor. Okay. Should I show you some like a collection of like big things, or are you gonna just search yourself for make something big? I showed you mine.
Yeah, would
Maybe-
be good. Would be
Yeah.
good.
Yeah.
Daniel, can I show yours?
Sorry, I was away.
Yeah. I'm gonna showcase your make something big. Is this okay?
It's not. Yes, of course, it's not good as yours. Ferdy. Yours is much better. Sorry.
Oh no, mine was a nightmare. Yeah, actually, funny side story to my make something big. Like we bought a milling machine from a Portuguese company. They're called Auplan, and so and they make a very nice, very big machine. It's like 3 by 3 meters. So they bought this machine for like a lot of money, and but they had an architect designing the room. I don't have Delio's page open anymore, or do I? So the architect designed the room for the milling machine exactly the same size than the milling machine. So by the time they they wanted to put the milling machine in, they realized like once you put the machine, you can't enter the room anymore. But the room was already built. So they asked Auplan to make the machine a little bit smaller. So they paid the same price than for a big machine, for getting a machine maybe half the size, just in order to be able to enter the room as well. Yeah, so maybe Daniele, you want to comment on this?
Oh, well, it's just because in the Fab Lab they didn't give me a table, so I needed to make my own table. I have to go on the top assignment, Ferdy.
Yeah, I think I just had it, but I lost it.
I'm sorry. Yeah, it was just basically a table that I needed to for my tools, so that the electronics and so on, because the tables from the Fab Lab were always full. And we had this nice CAM software, which is standard for Shopbot. Ferdy, you know this much better than me.
Yeah, it comes like the basic version, the vCarve comes for free with the milling machine. If you want the full-fledged version, where they just call it Aspire, you have to buy it. Yeah, but vCarve is fine for most of the stuff. The good thing about vCarve is that it makes the dog bones automatically. So there's like a round feature where you can just click on the edges and it makes you the dog bones. And you can choose between T-bones and dog bones, which is really nice. Yeah, I really like the vCarve. It's a nice software.
It's a very nice software, and I'm really sorry that it's not compatible with L-Sign. We have company for it.
Yeah, the only problem that it has that it sometimes flips your toolpath from the inside to the outside. But yeah, if you know it, you can just double check on the preview, and then there's no problem.
Yeah, I had some mistakes in my design because when I removed the tabs, some wood cracked out. Yeah, this is actually the control panel of the Shopbot.
Yeah, I've used this many years and I absolutely hate it because on the Shopbot you can't change the feed rate while the machine is running. So when you want to change the feed rate, you have to stop, change the feed rate, and start again. And I just don't get it. I hate it. And it's also very buggy. Like, boy, like how many times I don't know if this was like, but we had two Shopbots, like one really big one with like a 7 kilowatt spindle in down in the lower lab of Barcelona, and we had the small or like the 3x8 Shopbot up in Valdauda. But on both machines, like the big one was like one of the first Shopbots they ever made. So we couldn't use the regular firmware. We had to install like we had to customize it, and it would constantly give errors. And but we had the same trouble with the upper one, which basically was like factory. So yeah, I don't like the Shopbot software.
Unfortunately, we didn't have somebody expert as you, Ferdy, in the milling, I have to say, because we were all new. Our instructor didn't know how to operate the machine, and we spent lots of time with this buggy software to make it work. Yeah.
So you also used screws for hold down?
Yes, we can also use the screws. The board was not skimmed, unfortunately. The sacrificial board under it. Yeah. And yeah, I've used this machine more in Dubai than in Open Dot in Milan. Yeah, well, this one I think was well squared because the guys from Shopbot came to Italy to install the machine. It was very expensive, but it was very square. In Dubai, this machine was having the axis like open.
Yeah.
So when the machine was rolling to the end, you know, it was like losing some precision. Yeah.
And there is shown the job size. Okay.
Yeah, because we were worried about the screws. The final result was, yeah, the finish quality was not good. We were not using upcut, you know, sorry, downcut end mill for the first layer and then downcut for the rest. It was really sharp. Yeah.
I can see the tabs. Did you make a test fit piece?
No, we didn't make it. That's another mistake. Yeah.
Did you have to sand it a lot?
Yeah, we sanded a lot, and also we crunched it with the hammer, and then some pieces of wood came out and damaged the table. Yeah, I mean we were crappy at that time. I'm sorry. Yeah, really. Yeah.
Oh, but nice table. I like it.
It also wastes a lot of wood. I think it should have been done with less. Yeah, the design is not so good.
Yeah.
Yes, to tell you.
Yeah, unfortunately, like there's lots of designs in FabAcademy that are being done that are very unstable. So like if you can put in some diagonals, but this one should be fine, no?
No, this one was fine. I was jumping on the table afterwards.
Yeah, awesome.
Yeah, you see some problems. I mean, not here. You see here the sanding maybe.
Yeah.
But on the bottom, you see some wood has been removed because it's. Yeah.
So these are the T-bones, which work perfectly. Like if you wouldn't put this little ear in there, you couldn't fit this inside because the edge would be round. So whenever you have a 90-degree corner, you either have to make what they call a T-bone or a dog bone. And actually, let me quickly, if I go back to design, okay, no, my Fusion is crashing again. But there is a Fusion plugin for making the dog bones automatically. Fusion dog bone plugin. Let me see if my Fusion is. This is not Fusion credibly body. So the installation is a little bit hidden. Like you have to download this file, and then you have to go. Like I would like to show you, but Fusion is unresponsive. So this is the place where you have to copy the file, but then you still have to go. Yeah. By Fusion. Where was it? There's like a button somewhere. What was it? I know it's in utilities. You click on utilities, and there's like an add-on manager or something, and there you still have to go in and yeah. Let me see. Like I think the regular place to download it also has a little explanation on how to install it. Oh yeah, download the add-in, installation instructions. I think this is what we want. Yeah, so you go to this utilities and then on add-ins, script and add-ins, and then you can find it and you can click on Run at Startup. So it will start each time you start Fusion, and it will then appear once I'm in design. There's the place where I think it's like modify, and under modify, then this dog bone thing will appear. And I think it selects all your interior edges automatically. So you only select one edge and the rest is automatic. And of course you have to enter the size of your milling bit in there. Okay, Daniele, you have another recommendation for something to look at?
No, I think you did a very good job. You explained really well, lots of stuff, really. Thank you very much. And yeah, I was not always listening, but when I was listening, it was really well done.
Yeah. Ahmed, should we have a look at yours?
Yeah, sure. I also wanted to, yeah, you can try to find me.
Oh, there's probably lots of Ahmeds. I hope I'm spelling this right. Yes. You want to tell your story?
Yeah, I had some trouble getting an idea on how to make, and a friend of mine was moving at the time, and she also needed a desk. So I made a desk, but she's quite short, so she needed, let's say, not the standard measurements of a desk. And it was good for me because it could perfectly fit into one board of plywood. Yeah.
Yeah, it's a very good idea to make a first sketch on paper. Should I just scroll through and you comment?
Yeah, you can just go down to the final result. Yeah.
So this is the whole fusion process.
Yeah, at the time I was documenting in a very redundant way because I put fusion here and there. Yeah.
Yeah, but that's good. It's always better to have too much than not enough. Like if you design the dog bones by manually, then if you want to do this is more like the T-bone, and the dog bones, you can just see if my fusion is still alive. No, but you can, if you draw a 45-degree through the edge of your corner, and then you make a hole that is constrained with the center to this diagonal and with the line to the point, then you get the perfect T-bone. So let's say that this is your corner. No fill. And then you draw like a 45-degree line. Like I would like to show this in Fusion, but like my Fusion is unresponsive. And then you draw a circle and you put a coincident constraint between the center of the circle and this line, which will snap it to somewhere here. I can mimic this in Inkscape. So now this snaps onto my center. And then you make another coincident constraint between this point and the line of the circle. And this gives you the minimal dog bone that you could use. But you could also just do it like this or like this. If you do it like this, then sometimes the distance from here, you see that this distance is a bit less than the diameter of the circle. So your mill might not want to go in there. So you either have to make this a bit bigger, or just move it in a way that it cuts away a little bit more. But yeah, this was 3 years ago, and I think 3 years ago there still wasn't a dog bone plugin for. You can tell that Fusion looks completely different, yeah. So you had to manually make your dog bones.
Yeah, also designing in a parametric way was not a requirement at the time.
Yeah. And you used to use the software from Elsign, right?
Yeah, exactly. So for
Yeah.
2D cuts, we were exporting the XF, importing them, and then making the different layers. It was a very complicated workflow, but at the time, that's what we used to do.
Yeah. So this is the software that runs on the milling machine, and yeah, it's another CAM program, and yeah, it also works. Oh, what is this? Ah, yeah, this is the control pad. Yeah, I think I've never used it. Oh no, did I?
This, yeah, this
Probably I
is the
did.
control pad of Airsign, yeah.
Ah, yeah, and you use the vacuum, so this makes stuff a lot easier. The only problem with the vacuum is that it doesn't, like, once you get like smaller than A4 size, it is kind of at the limit of holding your pieces. So, but if you have tabs, then that's no problem. But if you had like a single A4 sheet of wood that you want to work on, I would rather screw it than vacuum it. There's different regions, so you can restrict the vacuum to smaller places. But yeah, just by testing and pushing it, like a lot smaller than A4 is like at the limit, I would say. Ah, yeah, this is the Z sensor. Isn't there another one installed on the machine?
The other one is
The one-
for measuring the tool height.
Yeah.
Yeah.
Yeah, this is the Z sensor, and there's another one for the tool height, right? Yeah. The one that I almost broke, but I don't really think it was my mistake. But for some reason, the machine didn't stop, so it like deformed the whole machine, which is probably the reason why the tool changer is not working anymore. Because I managed to hit the tool length measuring sensor too hard, which I don't get it. Like it should stop when it touches, but it didn't. Oh yeah, this looks similar to Daniela's, huh? Very nice. And your friend was happy with it?
Yeah, I mean, at the end, I think Daniela had it. She had it for some time. Daniela had it for some time. Yeah. Would you show Freddie Marcus Fleischer? I just sent the link to the chat. He did something interesting. It's just yeah, a reminder that you don't have to make 90-degree things or let's say perpendicular things. Also, you can also make curved, beautiful, well-designed things. Yeah, and also just a piece of advice. You're using a lot of wood and it will take a lot of time to design it and make it and so on. So it would be much better if you make something that you actually use or you genuinely like.
So this is the device for inserting mills into our collet chucks. So there's a place where you can secure the chuck holder and a special tool. And this is the one that I almost destroyed. Yeah, so this is a really nice curve bending example. Looks like he put some water on it for bending it more easily. Like steam also works very nice. You can actually put a plastic bag around your part and have a pot of cooking water with a funnel that goes into the plastic bag, so you can direct steam through your pieces. But yeah, in this case, this was sufficient. And yeah, really nice. I bet it's gonna be hard to make those fit after the bending, but it does fit and it looks beautiful. Wow, perfect. Yeah, if you search for curve bending, there's like lots of examples on how to do those bendy shapes. One thing to pay attention is the direction of your fibers. Some plywoods, they have a stronger and a weaker direction, so you can bend it nice in the x-axis, but less nice in the y-axis. Other plywoods are 50-50, so they bend equally in both directions. If your plywood has a preferred direction, you should test this before you decide on the orientation. There's many pieces where the direction of your wood grain makes a difference, especially if you're working like with solid wood. For example, for a leg of a chair, you don't want the wood grain to be horizontal because it will break much easier. So sometimes it's makes sense to have a look on this. On the arrange plugin, you can actually twist pieces. Like if you just, there's like a function that I can show you right now, but yeah, the arrange plugin takes care of this. So you can still turn pieces 90 degrees and the nesting will still work. And yeah, for the curve bending, you definitely have to do some tests before. It hardly ever works on the first try. And I've seen lots of sad faces when their pieces break on first usage. But yeah, there's some there's even some like curve bending designs that bend in 2 axes, which is quite amazing. But that's really tough. So yeah. Anything else interesting? Make something big. I could show Sam Kalish. Like his make something big was a boat, and he milled all the joints on the shopboard. Maybe this is not the right page. Like Sam Kalish was my hero. Like he was my go-to reference for FabAcademy. But he's just really, really good. So it was more like depressing than motivating to see his work. And he's not documenting very much. I know here there's some pictures of the CNC work he was doing. So it doesn't have to be like made from flat pieces of wood. You can go creative if you want to build a Zeppelin or something, or an airplane. Like there's no it has to use the big milling machine, but it doesn't have to be like a piece of furniture. Let me see if I can remember some nice make something bigs. Yeah. But I guess it's a good idea to just like go through like going through the classes at MIT is really fun. So if you just go to cba.mit.edu, and then you go on classes, then you get all the how to make almost anything classes, including the one from last year. And they're mostly really good. Let's just pick like one random one. And see what they did. Week 3. Wow, they did it in week 3 already. I know. Computer controlled machining, yeah. Should be this one, no? Ah, he made a laser cut prototype. Oh, that's also a very good idea to make a scaled model. Since in Fusion you can scale, you have all the parametrics. You can, if you're using the parameters, you can easily make like a small version of your something big and laser cut it first. Or actually, let me show you one of my students. Gabriel. Oops. So Gabriel came to Barcelona from Brazil. Actually, he was living in my place because when I discovered that he's paying for a hostel like 30 euros a day, and he was still looking for a flat. So I told him, hey, like if you want, you can just stay at my place. Which I was not sure if this is a good idea because you know, thought this might be a bit too close to my students, but it turned out was a really good idea. He's a super nice guy, and he did a really amazing FabAcademy. And so he also made a laser prototype first. He designed in SolidWorks. So using the parametrics, he could just make like a scaled down version. And he actually discovered some mistakes on the laser cut version, like this was too loose. And he added like another joint so that this would be more rigid. This is the mini version. And then, of course, we made the first test joint. And he was one of the first ones trying out to make rounded corners. But the only rounded corner mills we could find were those that you buy in like the regular hardware stores. And they usually have a bearing that sits on here so that you can follow a contour. And we just boldly cut off the bearing so that it looked like this. But then you can't just plunge into the material because it has a flat top. So we had to mill a groove first and then use the rounding bit to round the corners, which came out really nicely. So you can see that the gap is a bit bigger, so we could enter with this tool. And I think he even made like this is Fabula Barcelona. Oops. Oh, he made a very nice animated GIF assembly of the chair, so you could see like the chair putting itself together. And so actually he was invited to the Biennale de Arquitectura, you know, and to the Design Biennale in Italy, I forgot where it was. It's like the biggest design show in Europe. And Gabriel went to represent Brazil. And as you might know, the national dish in Brazil is arroz feijão, so rice with beans. So he made little cushions also with a sewing machine in the Fab Lab with like beans and rice. So it was the arroz feijão chair, which I thought was really cool. And so he actually managed to, during FabAcademy, travel to Italy, present his work, and come back. Okay, yeah, I think that's that's it for today.
Thank you so
If you have any
much,
more questions?
Ferdi.
Yeah,
Thank you.
you're welcome.
The cement sheeting we use in Australia only for cladding around the houses.
Yeah, it's good for cladding if it's not reachable by mean little kids that kick it with their feet.
Yes. Do you remember the hailstorm in Germany a
Yeah,
few years ago? And
yeah, this
all
was a long time ago.
the cement sheeting was all holes like this.
Oh my God, yeah. This was like if 86 or something.
No, it was after 2000, but it was more in the south.
Ah, okay, yeah. No, I remember one when I was a little kid, and it was hail the size of a tennis ball,
Yeah.
and all the cars, like you could see the dents on all the cars. Yeah.
Thank you so much.
Okay. Yeah.
Thank you, Ferdi.
If you want, we could have another session whenever you want.
Okay.
Just yeah. We should keep in contact on Discord, and I would also. Right now we are already quite many people on the regional meeting, so I kind of hesitate to invite Vasco. But Vasco, you should organize your own regional meeting. You have a lot of Fab Labs in Portugal.
Yes, but they are not doing FabAcademy, no?
FCT is doing FabAcademy, no?
But they have a student from last year, but the 2021 student quit, something like that.
Oh, okay. Or maybe
So,
just
yeah,
have a weekly chat with Luis. Like I'm sure he's gonna be happy to give you some advice.
Yeah, we didn't do it yet. We could do it. In fact, the original plan was to do a week in Benfica Fab Lab, another week in the FCT.
Yeah.
According to the expertise and all of that, but for I don't know, for some reason or because of the other student had quit, didn't go forward. At least for now, it didn't go forward. But we'll see in the next few weeks how it will go.
In the wiki under prep meeting, I posted the link to the list of the regional meetings. So you could also look if you find a lab somewhere somewhere close to you, maybe in Spain. Like I know that Nuria, she already has like 30 participants, so that's already a lot. But like getting to talk to Nuria once a week would be awesome for you. Like I'm sure this is going to completely change your FabAcademy. So I highly recommend that you connect with some other labs and see what they're doing, because this is really inspirational.
Okay. I'll talk to them and see what.
Yeah, and you can, if you have difficulties, I can write on Mattermost or just write me on Mattermost, and I will try to find a regional meeting for you.
Okay.
Ferdi, did you find out what happened to Wendy?
No, not yet. I will write her a WhatsApp and see what's going on.
Yeah. So the next in my time zone would be Singapore. Maybe I.
Oh yeah, Singapore would be Singapore. It's Stephen Chu, like he was one of my remote students in 2015. He's awesome, and he also has like a very high level of quality. So this would be definitely a good idea to talk to them. I hope the regional meeting is not in Chinese.
No, they speak English.
But Singapore is mostly Singlish.
Yeah, because they have so many people from India.
Yeah.
Half of the population. So
they speak Singlish. So it's basically English, but they put a ne or ne at the end. So what time is it now? So it's really funny. Like I'm sure you're gonna have a good time with them.
Yeah. Okay. All right. Daniele, talk to you tomorrow. See ya. Bye.
Bye.
All right. Thank you, Ferdi, for the lecture.
Right.
I was learning myself also some stuff.
Thank you.
Thank you very much.
Yes, thank you.